Hi everyone, in this video what we will see is we'll solve some problems on Fourier sine and cosine transform as we have promised in the last lecture, right? Okay, let's solve the first problem. The first problem is simple, very simple problem, of course, very natural problem that we usually solve. Find the Fourier cosine and transform of e to the power minus ax, okay? Problem. Find the Fourier cosine and sine transform of e to the power minus ax. Of course, a is greater than 0. That assumption is there. Solution. The problem is very simple. So what I will do is I will split this into two screens. One I will solve Fourier cosine, the other one I will solve Fourier sine. So the first one is Fourier cosine transform. Let me first assume this is f of x. So f of x equal to e to the power minus ax, right? Or here also f of x equal to e to the power minus ax. Remember, a is greater than 0. That assumption is crucial when you want to find out limits of e to the power x. Okay, so what's first things first? What is Fourier cosine transform of f of x? What's the definition? This definition says this is square root of 2 by pi into integral 0 to infinity f of x into cos sx dx. Okay, fine. Now that's going to be equal to square root of 2 by pi into integral 0 to infinity. What is my f of x? Which is e to the power minus ax into cos sx into dx. Yeah. Now there's a standard formula for such kind of expressions. So which is square root of 2 pi into the formula is e to the power minus ax divided by a square plus s square times whatever the constant here, which is minus a times cos sx plus whatever the b value here, which is s here. So s into sine sx. Okay, so that's the formula. Of course, the limits is 0 to infinity. Now all that we have to do is substitute the limits. I don't think so now it's new things to you. So substitute infinity for x, which will make this as e to the power minus infinity. Therefore, this goes to 0 as x equal to minus infinity. So the upper limit, of course, or s equal to plus infinity. So the upper limit is 0. Okay, so the upper limit is 0 minus the lower limit. For the lower limit, e to the power 0, which is 1. So 1 divided by a square plus a square times. Now here cos sx, which is cos 0, right? The cos 0 is 1, so a minus a, and sine 0 is 0, so that's going to be plus 0. Okay, so that's the limit. So therefore, this is going to be square root of 2 by pi into minus is plus minus a divided by, meaning yes, a divided by a square plus a square. So that's the Fourier sine transform, Fourier cosine transform of e to the power minus ax. Now the next thing is Fourier cosine transform of e to the power minus ax. It's exactly same. So here Fourier sine transform of f of x, which is square root of 2 by pi into integral 0 to infinity f of x into sine sx into dx. Correct? Now, of course, you can substitute the formula here. Integral 0 to infinity e to the power minus ax sine sx into dx. Then further, you have a formula and substitute it, you will get integral, you will get s by a square plus s square. That's all. Square root of 2 by pi into s by s square plus a square. So that's the final answer. Remember, similar formula is available. See, you can substitute it and then you'll find the answer. Final answer is square root of 2 by pi into s by a square plus s square. Yeah, let's solve one more problem along the line so that this video gets completed. Problem. So the question is Fourier sine transform. So find the Fourier sine transform of f if f of x equal to x 0 less than x less than 1, 2 minus x 1 less than x less than 2, then 0 otherwise. What's the solution? As usual, you see fs of f of x is equal to square root of 2 divided by pi into integral 0 to infinity f of x into sine sx into dx. Now, if you notice clearly, the integral from 0 to infinity has been split across three different integrals. So one starts at 0 to 1, the others is actually 1 to 2, the rest of them is just. So at this place from 0 to 1, the value of the function is x. From this place from 1 to 2, the value of the function is 2 minus x. And from 2 to infinity, the value of the function is 0. Okay. So therefore, let me introduce new page. So therefore, this would be equal to square root of 2 by pi integral 0 to 1 x into sine sx dx plus integral 1 to 2, what is the function? 2 minus x, right? So 2 minus x into sine sx dx plus integral 2 to infinity, 0 into sine sx dx. Okay, don't have to write it, but still. Oh, so that's the definition. Now this is square root of 2 by pi. Now all that you have to do is just find out the integration of this. I think this is pretty clear and neat. You see, this is simply x is the u, and then sine sx into dx is the dv. So you use the Bernoulli's formula to find out the integration of this. And again, the same thing here. Here also you choose the u as 2 minus x and then dv as this, and hence you will be able to do the integration by using Bernoulli's formula. So all that I'm going to do is just I'm going to write the answer, final answer. The substitutions. The final answer is 2 sine s minus sine 2s divided by s square. Okay. Remember, this integration is very simple. Huh? Hopefully you have done it. Okay. All right. So what is the next problem? Yeah, probably what I will do is I'll stop the video right now at this place, and I will see you in the next video to solve a slightly different type of problem. So instead of just solving a plain problem of finding Fourier sine and cosine transformations. All right, see you in the next video. Thank you, guys.